Space travel is something that has captured the fascination of people all over the globe. Some of our favorite science fiction movies and TV shows all revolve around the idea of traveling through the universe at blazing speeds. But this idea has largely been relegated to the realm of imagination until now. Reports state that scientists from NASA have finally perfected a new helical engine which breaks the laws of physics. Let's take a look at this new engine and if it is the future of space travel. For centuries, ever since we realized that every star we can see in the night sky is a sun just like our own, with perhaps its own solar system, planets, and possibly even life, humanity has dreamed of crossing the astronomical distances separating us from the ultimate alien destinations. Even the nearest star is more than 4 light years away, while the fastest speed a human-created spacecraft has ever traveled at, reached by NASA's Juno mission, is a mere 46 miles a second. Even at that speed, it would take more than 4,000 years to reach the nearest star. There are 2 limiting factors: the current limits of our technology and the laws of physics. Advances in fields like laser sails, nuclear propulsion, or producing and controlling either antimatter or dark matter could provide a game-changing technological breakthrough, but appear to lie far off in the distant future. But physics-defying technologies, despite being often touted as the future, are fundamentally flawed. There are 4 fundamental forces in the universe: gravitation, electromagnetism, and strong and weak nuclear forces. The first of these forces is described by general relativity, the best theory of gravity we've ever concocted, and one that's passed every observational or experimental test we've ever performed. The latter 3 are described by the Standard Model, which describes all the known particles and their interactions exquisitely, passing every classical and quantum test we've ever devised. While future technologies might unlock the potential of the nuclear forces for space travel through fission, fusion, or even the annihilation of exotic particles with the normal, stable matter we find all around us, all of our conventional propulsion technologies rely on some type of chemical-based or electromagnetically based interaction or reaction. For every action, there's a reaction. That is the principle on which all space rockets operate, blasting propellant in one direction to travel in the other. But one NASA engineer believes he could take us to the stars without any propellant at all. Designed by David Burns at NASA's Marshall Space Flight Center in Alabama, the helical engine exploits mass-altering effects known to occur at near light speed. It has been met with skepticism from some quarters, but Burns believes his concept is worth pursuing. To get to grips with the principle of Burns's engine, picture a box on a frictionless surface. Inside that box is a rod, along which a ring can slide. If a spring inside the box gives the ring a push, the ring will slide along the rod one way, while the box will recoil in the other. When the ring reaches the end of the box, it will bounce backward, and the box's recoil direction will switch too. This is action-reaction, also known as Newton's third law of motion, and in normal circumstances, it restricts the box to wiggling back and forth. But Burns asks, what if the ring's mass is much greater when it slides in one direction than the other? Then it would give the box a greater kick at one end than the other. Action would exceed reaction, and the box would accelerate forwards. This mass change isn't prohibited by physics. Einstein's theory of special relativity says that objects gain mass as they are driven towards the speed of light, an effect that must be accounted for in particle accelerators. A simplistic implementation of Burns's concept would be to replace the ring with a circular particle accelerator in which ions are swiftly accelerated to relativistic speed during one stroke and decelerated during the other. But Burns thinks it would make more sense to ditch the box and rod and employ the particle accelerator for the lateral as well as the circular movement, in which case the accelerator would need to be shaped like a helix. It would also need to be big, some 200 meters long and 12 meters in diameter, and powerful, requiring 165 megawatts of power to generate just 1 Newton of thrust, which is about the same force you use to type on a keyboard. For that reason, the engine would only be able to reach meaningful speeds in the frictionless environment of space. According to Burns, the engine itself would be able to get to 99% the speed of light if you had enough time and power. Propellant-less proposals aren't new. In the late 1970s, Robert Cook, a U.S. inventor, patented an engine that supposedly converted centrifugal force into linear motion. Then, in the early 2000s, British inventor Roger Shawyer proposed the EM drive, which he claimed could convert trapped microwaves into thrust. Neither concept has been successfully demonstrated, and both are widely assumed to be impossible due to violation of the conservation of momentum, a core physical law. Martin Tajmar at the Dresden University of Technology in Germany, who has performed tests on the EM drive, believes the helical engine will probably suffer the same problem. He states that all inertial propulsion systems that he has ever studied never worked in a friction-free environment. Burns has worked on his design in private without any sponsorship from NASA, and he admits his concept is massively inefficient. However, he says there is potential to harvest much of the energy that the accelerator loses in heat and radiation. He also suggests ways that momentum could be conserved, such as in the spin of the accelerated ions. This has not held him back, though. He states that he is prepared to be embarrassed if he is wrong, but if he is not, humanity will have discovered something truly revolutionary. NASA is not the only organization looking for ways to travel faster in space. Elon Musk is taking science fiction a step closer to reality. His company, SpaceX, says it has created a thruster system that defies physics and has successfully tested it. The rocket propulsion system uses electrically charged gas and can achieve speeds up to 65 kilometers per second, or about 135,000 miles per hour. The engine is made from super lightweight carbon fiber fuel tanks with cold gas thrusters. It doesn't use any type of propellant, meaning it does not expel any byproducts into space. Instead, the engine produces thrust by accelerating superheated plasma with magnetic fields, which also means no fumes are being expelled from combustion. These types of engines are known as electric thrusters, but they work very differently from those used in SpaceX's Falcon 9 rockets. These thrusters create thrust by propelling pressurized gas, whereas electric ones produce a charged plasma that emits ions to push a craft forward. The electric engine developed by SpaceX is reportedly more powerful than conventional gridded ion thrusters and could power manned missions to Mars and beyond. It could also cut down on travel time for space-bound cargo because it requires less propellant, which can be expensive to launch into orbit. The technology is still being tested, and further development is needed before it will be ready for space flight. It has been submitted for peer review, and NASA experts think it has potential, at least on paper. Some say it's impossible to travel at high speeds through space, but that hasn't stopped Elon Musk from claiming he can do it. His idea is to create a light speed machine that will take us to Mars in just 70 days. Such an engine defies physics and would mean traveling faster than 186,000 miles per second. There are a few ways that we could travel at light speed, but first, we need to understand how light works. As it travels through space, every atom in its path interacts with it. This slows it down and even stops it completely if there's no matter around to pass through. Because of these interactions, light has a maximum velocity of 186,000 miles per second, meaning that's as fast as it can go through space. Since nothing can travel faster than light without breaking the rules of physics, if we want to catch up with a distant star in our lifetime, we have to find another way to get there besides traveling directly towards it. The current way that we measure speed is the distance over time. To travel at light speed, or 186,000 miles per second, you would need to accelerate past that velocity until your speed was 186,000 miles per second, then hold it there for an infinite amount of time. This velocity is referred to as c and was defined by Albert Einstein in his theory of special relativity. We haven't yet reached what most consider to be light speed, although many experiments and theories suggest that we may one day be able to approach it or even surpass it within our lifetimes. Until very recently, it has been generally accepted that nothing in our current state of technology could even begin to move at a velocity close to what we consider light speed. Some estimates place us thousands or even tens of thousands of years away from ever reaching it. That being said, we are often surprised by what science and technology can accomplish, and scientists have now managed to make an engine capable of reaching a mere 10% of light speed, defying these previously held assumptions about what is possible for our technological capabilities in today's day and age. The invention of an engine that could reach such high speeds would allow us to travel through space much more efficiently than before. If you liked today's video, please check out this one on planets in the universe, which may be better for life than Earth. Do you think the Lightspeed engine will become a reality in our lifetime? Please share your thoughts in the comment section below.